Implicit differentiation today. Implicit differentiation, super cool because we want to be able to deal with explicit equations and implicit equations. An explicit equation is where f of x is solved for. Do you know how to take the derivative of f of x is equal to 3x squared minus 5x? How about y is equal to the sine of 4x?
Yes.
Yeah, you know how to take the derivative of those. That's because y, or f of x, is explicitly solved for. But the question is, what if we had x squared plus y squared is equal to 100? Well, in that situation, y is not explicitly solved for, is it? That raises us a question for us about how do we go about that. And some of you are getting smart right now. You're saying, well, I'd subtract the x squared and I'd square root both sides and have y solved for, right? Great. How about this? You're going to solve for y there? Explicitly? I don't think so. And so what do we do? How do we handle that? And so back when calculus was really being put into its form that we see it really now, a guy by the name of Isaac Newton and his cohort Leibniz, they were working together and they had different notation. This was really Newton's notation, and this was the notation of Leibniz. And these all mean derivatives, but this means the derivative of the function. Derivative of f with respect to x. This means derivative as well with respect to x. But note that it does not name the variable that you're taking the derivative of. Everybody see that? What do you think this means? Everyone want to take a guess? Derivative of y. It names y with respect to x.
So much.
As you see these laid out for you, we're going to see them come up in this example. I might not do just a great job of explaining this, but you're only going to see it one time through, and you're going to be able to just kind of memorize what to do in the meantime, okay? So here we go. The derivative of the circle, if you didn't notice, this is a circle. X squared plus y squared is 100. The radius is 10, centered at 0, 0. This is centered at 0, 0 with a radius of 6. So what we want to do is we want to take the derivative of x squared plus y squared is equal to 36. What would you say is the derivative of x squared? Notice how every time we take a derivative, what happens to the power? It reduces 1. So one way to think of this is that it absorbs that x. You see what I'm saying? So it's like, where did the x go? It got absorbed by the derivative. Plus, what would you say is the derivative of y squared?
2y.
So we're going to say that one of the y's got absorbed by the derivative. What's the derivative of 36? 0. Dx over dx is just 1. So we get 2x plus, and instead of writing dy over dx, I'm going to write what we say is a derivative of y, which is namely y prime, times 2y is equal to 0. Everybody agree with this exchange that dy over dx, I can exchange that with y prime, that those mean the same thing, the derivative of y. Now, I solve for y prime. What would you do to solve for y prime? Yep, subtract my 2x and divide by my 2y. And there's our derivative. So, a couple things. You said it was a circle, so and with a radius of 6. So if I draw it just like this, I've got 6, 6, negative 6, 6, so on and so forth. If you want to know the slope right here, you plug in the coordinate 0, 6. What is the slope right up here? 0. Notice if you plug in 0 for x and 6 for y, you get negative 0 over 6. Is that 0? Absolutely. What is the slope here? Undefined. Notice if you plug in the coordinate 6, 0, you do in fact get negative 6 divided by 0. Is that undefined? Yes. So you can plug in the x and the y in order to produce a slope, and it accounts for these types of things that are not functions. This is not a function. But the key here, folks, is when you're doing implicit differentiation, whenever you take the derivative of an x, you just do it normally. Whenever you take the derivative of a y, you attach a y prime. That's it. That's all you do. So flip it over. Go to example 2. It says use implicit differentiation to find the derivatives of the following equations. We could solve for y here, but we don't have to. I'm going to use implicit differentiation in that y is not explicitly solved for. What is the derivative of 3x squared? 6x. What is the derivative of negative 4y? Negative 4, right? And then since there's a y, we attach a y prime. And that's what we want you to get used to these next few examples. And the derivative of 4x, 4, we are going to solve for our y prime. And then I divide by negative 4. Y prime is equal to 4 minus 6x over negative 4. I should make sure that I simplify my fraction. I would have a negative 1 plus 3 halves x.
That's it?
Yeah.
Oh, that's like the okay.
What is the derivative of y cubed? 3y squared. Mine times what? Y prime. Attach a y prime every time you take a derivative with a y. Minus 5 plus 2y prime is equal to 3. What's different about this example compared to the first one? There's 2y primes. We've taught you how to prepare for this back in college algebra. First of all, I'm going to get everything that doesn't have a y prime on the other side and everything that does have a y prime on the left side. So I have my y primes on the left side, and over on the right side, I now just have 8. Everybody should remember this because you're an extremely intelligent group. What do I do in order to isolate the y prime? Factor it out. Thank you, Ava Murray. So now I only have a y prime times 3y squared plus dos, which is Spanish for 2. And finally, I divide, and I get y prime is equal to 8 over 3y squared plus 2. What do you think?
Piece of cake upside down.
Piece of cake upside down? Okay, you do letter C then.
Okay. Shouldn't say it once.
I'm going to slowly work behind you.
Wait, why is mine exactly backwards?
Mine's also exactly backwards.
But that's fine. Like I have.
I don't know.
Blah, 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 blah.
Oh, I see. Okay.
What if you have 1 minus 9x squared over 16y cubed minus 4y? Are those the same?
Wait,
Add a negative.
Yeah.
yeah, yeah, because it's multiplied by negative, right?
Top and bottom.
Yeah.
Yeah. So as long as the top and bottom. So it all depends on, you probably put your 16y cubed on, you probably just moved them to the other side, right? All depends on where you moved them. These are the same, just different top and bottom by a factor of -1. That's it. Yes?
Do you want us to factor it anymore, like take out 4y
The fact that it factors doesn't necessarily make it more simplified. It would be, to what purpose are we factoring? If it would allow you to cancel something off, then yes. But in this situation, no. All right, good job. You guys are very well prepared for your assignment, except for we need to do a couple more problems here. What do you think about letter D? What do you notice is different about this? So what about the XY? What about the multiply?
Well, it would just end up
Divide
with
that.
3y. No. Could you just do 3y?
How do you
Can't you just take out like a 3x?
Do you have to do the like
Product.
multiply?
You can take out 3x.
What?
Do you have to multiply it out to the product?
Product rule. Yes. That's F, and that's G.
Wait, so what's F and what's G?
That's what like really enthuses me to teach you more, is when I hear the groan. It's like, yeah, let's go. All right, derivative of 3x is 3 times y
Right.
plus 3x times, what's the derivative of y? 1y prime.
Oh, right.
You good with that? Plus
It's 9.
9 equals
10y
10y prime.
y.
Once we have it there, the rest should be simple, right? I'm going to gather my y primes on the right-hand side. I have a 3y plus 9 is equal to 10y y prime minus 3x y prime. We gather, we factor out that y prime. And I divide. So I have 3y plus 9 over 10y minus 3x is equal to y prime. How about that? Hey, come on. At the end of the day, one thing that's beautiful about math is you guys walk into some classes and you say, I already knew that, or I could have looked that up on my own. But every day you come to this class, you learn something you don't already know. You know what I mean? And that to me is what makes things exciting. If you go on to college, and I just had this conversation with a student the other day. She's going on to college, she's going to get a degree, and she's going to be super, super successful. She's going to be great at what she does. But I said, take some classes that are going to push your mind a little bit. You know what I mean? Like if you're going to go for 4 years, don't just take stuff that you already know how to do. Push your mind and learn some things you don't already know how to do. Like math. Okay, 2 more. Trigonometry works quite well as well. Sine of xy. What do you think? Change. Excellent. Good job, man. You guys are smart. Sine of u and xy. What's the derivative of sine of u?
Cosine.
Cosine of u. Remember my arrow to plug that back in. I need the derivative of xy. Product rule. Derivative of x is 1 times y plus x times y prime.
Oh, shoot.
Y prime. If you were to do another box, which one would be by itself?
It's okay, Riley.
Never mind.
I will multiply these. Cosine of xy times, I need a parenthesis around there, y plus xy prime is equal to If you see a different variable such as c or n or a, that is just a constant. What is the derivative of c times y, do you think, if c is just a constant? cy prime.
No.
Any suggestions for how I isolate the y primes? I can't subtract the xy prime over to the other side right now. What do I have to do first? Yeah. So we will have a y cosine of xy plus xy prime cosine of xy is equal to cy prime.
This is where we lost.
Now what? Yeah, you do. Yep. So y cosine of xy is equal to cy prime minus xy prime cosine of xy. What do I do now? Take out a y prime. Y cosine of xy equals y prime times c minus x cosine of xy. And finally, we divide. And I get y prime is equal to y cosine of xy divided by c minus x cosine of xy. That is indicative of a kind of problem I would expect you to do for the test. So try the next one on your own, okay? Set it up, see what you come up with, take a gander at it.
It's like the music.
You want to see it? I can show you.
Nobody's texting.
That's so funny.
So skinny.
Bro, what? My cousin was like, "Hey, stop."
Danica, you are gonna throw your Kleenexes away at some point, right?
Yeah.
Okay.
Let's see what he does. That's not mine.
Oh, that's not yours?
No.
That was from last hour?
Yeah.
Oh.
She been here.
Oh, what am I? I'm being a little silly.
Sorry.
Sorry.
I'm gonna need to get out my race. My big one.
Is it like whoops on it?
No, it's cracked in the middle. I think I lost it too. Another mistake.
Oh my God.
Wasn't it nice of Mr. Snavely to join us today?
Yeah.
He's exercising his brain
My brain is so exercised.
and remembering his fond days of calculus.
Okay, here's where I am. This is where I start. Here's where I start.
I see some erasing, which means that you're thinking critically.
I don't know what I've done. Stop shaking.
Stop shaking.
Right, right. So I must be on the right track. I must be.
Yes.
Gaslight
Yes.
cute girl. Mm-hmm.
Right.
This makes me really upset.
Okay, I'm gonna set it up as you're working your way through.
It's not.
It's not. Stop.
Stop. Don't talk to me.
Stop.
okay, this can't be right.
So my first question is, did you see that the derivative of the square root of x plus y, you should get y prime plus 1 on top, and the bottom 2 roots of x plus y. Got it? Good job, Mika. Questions on how I came up with that?
No.
Then the right-hand side, I use the product rule, and I get a 4y plus 4x y prime.
I got that part.
I should not have saw it in there.
I'm boxed.
So, all right. So Jacob says that he's boxed,
Wait, maybe not.
which I get it, but I would say over the years, I have many people that get to that spot, and when you have a fraction equal to a fraction, I would say the way you get unboxed is you go ahead and you just cross multiply.
Yeah.
And so this is going to get a little bit ugly, but it will produce our result that we want. We have a y prime plus 1 on the left side. On the right side, I'm going to have an 8y roots of x plus y. Plus 8xy prime roots of x plus y. And now, once we do that, the process is always the same. Gather the y primes on one side. Gather everything else on the other side. If I factor out the y prime, I notice it's going to be a 1 minus 8x roots of x plus y.
Okay.
Sir?
On the top, shouldn't it be minus 1 because you're minusing the 1?
I'm sorry. Yep, thank you. Thank you. Would be on task, Grimace.
I'm like really ready to see my test.
I'm
I was scared and now I'm like,
I agree. I'm getting antsy.
All right, so you guys are ready to work on your homework over your next 3 days.
Hey.